about estimation of parameters. The term parameter estimation refers to the process of using sample data in reliability engineering, usually times to failure or success data, to estimate the parameters of the selected distribution. Several parameter estimation methods are available. So this present an overview of the available methods used in the live data analysis. More specifically, we need to be familiar with the relative simple method of probability plotting and continue with the more sophisticated methods of rank regression, maximum likelihood estimation, and Bayesian estimation methods. So this will be the lesson 1, illustrating the T-distribution. The T-distribution, which also known as student T-distribution, is a probability distribution which is utilized with estimating parameters of a certain population in case of the sample size is small and or the population variance or standard deviation is unknown. It is like with the Z distribution that is bell-shaped and symmetric about the x-axis but flatter and more spread. The T-distribution, as I mentioned earlier, as you can see as what we have here, we have a normal distribution and we have the T-distribution. So we need to take note that Z-test is only used when the population standard deviation or variance is known and or the sample size is large enough. But for sample sizes which are small, sometimes the population standard deviation or variance is unknown, rely on the T-distribution. Those value or host value can be used as what we have here. So this will be the formula for T-distribution. Again, the T-distribution has been used for sample sizes which are small, and sometimes the population standard deviation or variance is unknown. So this will be the formula for T-distribution. So equals sample mean minus population mean over standard deviation of a sample and of course as a sample size. There is a lot of different or family of T-distribution. It's particular from each determined by its degrees of freedom. So the degrees of freedom refers to the number of independent observation in a given set of data. The number of the dependent observation is sample size minus 1 or symbols. That is df is equal to n minus 1, where df is the degree of freedom and n is the sample size. Hence, given the sample size of 9 will have a degree of freedom of 8 and it will be given a degree of freedom of 14 will mean a sample size of 15. However, for some other applications, degrees of freedom can be calculated in a different way. Then, with any statistics that have a bell-shaped distribution which is approximately normal, the T-distribution can be used. This means that the population distribution must be normal, symmetric, unimodal, and no outlier. So, the p-value corresponding to the absolute value of the t-test statistics or t-distribution is computed for the degrees of freedom. As I mentioned, df is equal to n minus 1. So, in order to get the t-value at t-distribution table, so this will be the t-distribution table. This one, no? This will be the t-distribution table. Okay? Is shown above, which is the consists of the degree of freedom, which is the numbers at the leftmost. So, degree of freedom is 1 to 28, for example. Then, the leftmost column, that is the leftmost column, no? And alpha, which is some of the special areas of the topmost row, and the t-values were located at the right of the degrees of freedom and below alpha. So, the alpha is 1, 0.05, 0.025, 0.01, 0.005. Now, identifying the t-value. To denote the t-value, it is conveniently written as the t of sub alpha, comma, degree of freedom. So if you are asked on the t-value denoted by t, that is 0.05 and 8, means the t-value corresponding to alpha 0.05. So 0.05, this will be the 0.05 in our alpha. Then, degree of freedom is 8. So this will be our degree of freedom of 8. Then, therefore, our t-value is 1.860. To look for this value in the table, first locate the alpha. So that's why we locate this one first on the top row, and then the degree of freedom, no, the degree of freedom on the leftmost column. So again, this will be the degree of freedom. Then the intersection of the alpha 0.05 and the degree of freedom 8 is 1.6860. Okay? So, as what we have here, no, we have the degree of freedom, for example, 1 to 8. Then, our alpha is 0.1 and 0.05. So, for you just simply try to look in our t-distribution table, and we could able to find this value. Okay? Now, determine what is asked based on the given data below. So, based on the given data here, no? So, for number 1, we have the n is equal to 14. Alpha is 0.01. So, therefore, we need to find out the t value. So, by this time, the given is the degree of freedom and the alpha. So, number 3, so the missing is the number of cases of the n. For number 5, find the t-value when, of course, as what we have here, no? The given, based on this one, we have, of course, the t-value of the population mean, no? Of course. Then, this one, the population mean is 42. Our mean is 44, or the sample mean is 44. Our standard deviation is 5, and our n is 25. Now, so solution based on the given, no? For example, number 1 a while ago. So that is n is equal to 14. Our alpha is 0.01. Then our df is equal to 1.350. So this is 13. So, if n is equal to 14, so df is equal to n minus 1 is equal to 14 minus 1, that is 13. So, therefore, the answer is 1.350 in our T-distribution table. For number 2, so df is equal to 10, alpha is equal to 0.025, we can get 2.228. So, therefore, we can get 2.228. For number 3, so this will be the solution, no? Since df is 27, df is n minus 1, that is 27 is equal to n minus 1, 27 plus 1 is equal to n, then n is equal to 28. Okay, so this is the simple way now we'll be able to get if the missing value is n. Okay, find the t-value when the population mean is 42, the sample mean is 44, the standard deviation is 5, and the n is 25. So based on the given formula a while ago, no, about on how to get the t-distribution value, so based on the given formula, that is t is equal to sample mean minus deducted by population mean over square root of n, s over square root of n actually. So direct substitution, so we have 44 minus 42 over 5 square root of 25 is equal to 2 over 5 over 5 is equal to 2 times 5, that is 10 over 5. So therefore this is our t value is 2 based on the given example in our example number 4, I mean. Now, identifying percentiles using T-distribution. So, percentile is one of the measurement in the statistics which tell the value below in which an observation percentage in a set of observation falls. So, as what we have here, for example, no, your score 70 in an exam and it was mentioned that you score at that 85th percentile. It means that 85% of the score are below you and 15% of the score are above you. Okay? So, in finding the percentile for a t-distribution, t-table can be utilized as it is a number of a statistical distribution whose less than the probability is the given percentage. So, if you are asked on the 80th percentile of the t-distribution, with respect to each degree of freedom, that refers to the value whose left tail or less than probability is 80%, 0.8, and those right tail or greater than probability is 20% or 0.2. So, determine what is asked based on the given data. Okay? So, n is equal to 14, degree of freedom is 10. So, percentile is equal to 95. So, solution as what we have here. To find the value of 95th percentile, identify first the degrees of freedom. So, df is n minus 1, that is 14, of course, based on the given, 14 minus 1, that is 13. Then, to solve the 95th percentile, we need to understand first its implication, which is to get the t-value that is less than the probability of 0.95. And the right tail probability that is 0.05. Based on the table, the 95th percentile is 1.71 as what we have here. Then for number 2, okay, so the 90th percentile is 1.372. How about the length of confidence interval? Estimating consists of either giving a certain value or given an interval. When an interval estimate has an attached confidence coefficient, it will be called confidence interval. It is arranged with lower limit and upper limit used to estimate population parameter. The lower and the upper limit of the interval is within the certain level of confidence. So, confidence interval. To get the confidence interval, we use either the following. So, we have here the formula for estimating population mean when variance is known or sample is greater than 30. And we have also a formula estimating population mean when variance is unknown and sample size is less than 30. So, if that is greater than 30, we use this one. Less than 30, we use this one. Wherein, of course, X bar is sample mean, the population standard deviation, and the sample size. Then the margin of error refers to the maximum allowable difference between the sample and the true value. So, confidence level 95%. Then, of course, 9 and our n is equal to 20. Then, x bar is equal to 56. So, based on the given formula, and of course, based on the given, no, we could able, in direct substitution, we could able to get the 7.88 with, so the confidence interval is from 52.6 to 59.94 with a width of 7.88. So another example, so this time, the given is the confidence level is 95%, standard deviation is 3, n is equal to 15, then sample mean is 25. So, therefore, confidence interval is 28.27 to 31.24 with a width of 2.48. So, identify the confidence interval estimate and compute its width based on the given data. So, this will be your activity. Okay, but again, this will be the solution for that given activities. Okay, so if the confidence level is 90%, our population is 12.5, our N is 64, then the sample mean is 42. So we'll be able to get, of course, direct substitution in computations. Then we will be able to get the confidence interval is from 39.43 to 44.757 with a width of 5.14. So for number 2 solution, same as what we did a while ago, but this time the given is the confidence level is 98, the standard deviation is 15, n or number of cases 10, then our sample mean is 21. So again, direct substitution, and we will be able to get the confidence interval of 7.62 to 3.438 with a width of 26.76. Sample number 3, this time the given is the missing is the standard deviation. So we can get 20.4 to 26.6 with a width of 6.2. Yes. For number 4, the missing, of course, is the population mean. So this time, we could able to get 25.69 to 30.31 with a width of 4.62. By the way, if you are asking, how do we come up with the width? What we're going to do is to subtract this one, 30.31 minus 25.69. So, we can get 4.62. Excuse. So, So the next will be appropriate sample size using length of the interval. In estimating, the sample size need to be considered in order to make it more valid and reliable. Because in research, our panel always asking about the validity and reliability of our results. The number of members or element of a population must be taken into consideration aside from being manageable. The selected samples, either through probability and non-probability sampling, must be taken at least to each minimum need to go through the study. The researchers will be able to make a feasible conclusion about the parameter of the certain population being studied. So, in order to solve for the least number of sample size given a certain confidence interval, this formula can be used. No? So, where, of course, this will be the population standard deviation. This is the maximum allowable deviation or the marginal error. So, example, a bookstore confirms that the durability of their textbooks follows a normal distribution with a standard deviation of 5 years. How many textbooks must be selected as sample if you wanted to estimate with 99% confidence that the sample mean is within 2 years of the true population mean? So, given, therefore, you need to select 42 textbook as sample from the given bookstore to 99 confident. So, actually, this will be the answer, no? So, our population is equal to 5. Our CI is equal to 99% or the confidence, no? And our D, no? That is equal to 2. So, direct substitution, we could able to get 41.47 or 42. So, another example, identify the number of sample needed in each problem. So, we have 3 problems here. And this will be the solution for problem number 1. So, given D is equal to 12, CI or confidence 93, population is 55, then N is equal a question mark. So, we're looking for the N. Direct substitution, we can get 69. So, therefore, the samples, 69 samples are needed in order to achieve a 93% confidence level. For problem number 2 actually, so given the sample is given, we need to find the sample, no? So based on the given computation, we're required to have at least 172 sample for us, no? Or in order to achieve the 99.5% of confidence level or the CL. So for number 3, it was reported that the student who do not online business during this pandemic crisis earns money with a standard deviation of 2,000. If you wanted to estimate with 96% confidence the mean income of student within 450 of the true population mean, how many students should you select? So again, find sample. So direct substitution, we can get 83 samples to have a 96% confident that the sample mean of income is within 450 of the true population mean. Okay, so that's it. Again, so this will be our references. Albacea, Sita, DJ, Banigon, Ricardo. We have Stat Trek, dummies.com, and of course, the Department of Education in our country, Philippines. Thank you. Okay, so this time, this will be your activities. Now, solve the following and post your answers in the comment section. Identify the confidence interval, estimate, and compute its width based on the given data. So, you have 1 to 4 activities. Good luck! It is very important to know on how we'll be able to compute the t-value and apply and use the t-distribution table. This is one way we'll be able to say that our research was valid and reliable. Thank you and good day, everyone.